Okay, so we're given this power series and we want to convert it into something else so that we can use a geometric series. Now, I am in a bit of a hurry, so let me just throw this at you. And then later on, I can talk more about this if you need more videos, if you're not in a hurry. So what we usually do is we go straight into this expression here, where we take the limit of the next term over the previous term. So here's what we do. So let's take this piece here, that x to the 4n, let that be your a sub n. That's your sequence. Just this part here is a sequence. Let's build this. So we have limit as n goes to infinity, absolute value. Now in the denominator, it's just the original sequence, x to the power of 4n. But in the numerator, we have the next term of the sequence. You see, what would be a sub n plus 1? Well, you go to the original, and instead of n, you put an n plus 1. And if you clean that up a little bit, if you distribute the 4, that'd be 4n plus 4. And that goes up here, x to the 4n plus 4. I can't really tell you why we do this. I'd have to brush up on this, but I'm pretty sure this is what we do. Okay. Now look, we can clean this up here. This is the same as the limit as n goes to infinity of x to the 4n times x to the 4. Right, if we reuse our little algebra skills from back in the day, our exponential rules, right? You can separate this as that. And I did that because you see that these are actually gone. Those will go away. So all we have left is the limit as n goes to infinity of x to the power 4. Now notice that this here, this does not depend on the variable n. And for that reason, this can be pulled out to the front in its absolute value still. And then since there's nothing left inside the expression, it would just be 1. And this here, that is just going to be 1 because there's no n remaining. So the only thing left from all of this equals. This would just be the absolute value of x to the 4. Now the condition, the understanding, is that the infinite limit of this be less than 1. It has to be less than 1 for this to converge. So let's grab this up here, and we have the absolute value of x to the 4th has to be less than 1. Now the question is, for what x values is this true? That's the question we have to ask ourselves, question mark. Well, there's many ways of making that decision. For what x values is this true? Amongst those reasons would be a graph. What does the graph of x to the 4 look like with the absolute values? If you look on a calculator, the graph of this here on the left-hand side, not the whole thing, but just the left-hand side, that graph would look something like this. And what is it that we want this graph to do or to be? We want it to be less than 1. And the graph of 1 looks something like this. So the x values that work are the x values between here and here. This is called your interval of convergence. It's from here to here where this works. You'll notice that this is -1 and 1. So your interval, I think they wanted an interval of convergence. Your interval of convergence would be from -1 to 1. Okay? And then your radius would be, well, here the radius would just be, the radius is how much it extends. It extends 1 unit in either direction, right? Because the whole thing has a gap of 2 from -1 to 1. That's a separation of 2 spaces. You chop that in half. That means the leash or the radius in either direction from the center, you can extend 1 unit. So the radius for sure is going to be 1, and that's going to be your interval. Now, when they said to change the index refers to this here. But exactly which component were they referring to for part A? I'm not too sure. Maybe they just want to see all of this for part A and this here for part B. So I'll let you make that decision.